Alright, here we go, guys. Starting on 26 here. Scatter plot shows the monthly high temperatures for Austin, Texas in degrees Fahrenheit over a 12-month period. Which function best models the data from month 1 to month 9? Okay, so I'm trying to figure out a line of best fit in between this selected range here. It's kind of hard for me to draw straight lines on my iPad here. But something in between all of those points there that matches and kind of hits all the data. So what I'm going to do here on this one, I'm going to sketch a line of best fit. What I think happens with this graph here. Whoa, happened, like disappeared on me. And you want to try and draw this, and sometimes we need to erase a little bit. We want to try and draw it in such a way where you got a couple of points above and then a couple of points below the line of best fit. It's probably not even perfect there, but that might help me at least figure out which of these definitely could not be it. Now notice all of these graphs here, they're in y equals mx plus b form. So if these are all in y equals mx plus b, what I would look at first are the different y-intercepts. I can tell a lot about what's going on with the graph based off the y-intercept and what I have up here. So let's start here looking at these two y-intercepts. You have 111 and 130. Based off of my sketch, it looks like my y-intercept is maybe around 91 or possibly even 90. So definitely, 111, that'd be way up here. So definitely couldn't be that. So that'd be starting too high. You wouldn't be able to get your graph to hit all those points. Same thing with 130. That's even more drastic. It'd be way up here, and you can't get your line to hit all those points. So those are definitely not the best options here. Now, depending on how you draw it here, 85 and 90, those could be kind of close here. 85, though, it's starting way down here. So unless you draw your graph or your line of best fit, a little bit off there, you might get that on accident, but I think 90 is probably the closest because you want a couple of points above and a couple of points below. So 90 is probably the best approximation for that. Now, I have seen students in the past, these aren't too hard to figure out the actual values here because I think each one of these ticks, I think they're going up by 2. So I guess each little half tick here is, going up by 1 right there. So you could actually go find all these order pairs and then use regression, but that's going to take a long time there. I would just use the line of best fit, just kind of sketch it, and then that's what we did there, and we chose the best one there. So that's all I would do on that one. 27 given f of x is equal to 6 parentheses x minus 1. What is the value of f of negative 8? All right, this question is all about understanding function notation. When you see this notation, f of negative 8, that means evaluate, spell it right here, evaluate when x is equal to negative 8. That's essentially what this notation means here. It's function notation, a little different. All that means is we're going to go and plug in, for the x, we're going to go plug in negative 8. We just got to be careful on when we're doing that there. So I'm going to go 6 parentheses, 1 minus, and then negative 8. So yeah, we got to be kind of careful on that. All right, when we're subtracting a negative, it's the same thing as adding. So I'm going to change that to 1 plus 8. And then you got that times 6. So then obviously that's 6 times 9. And then that's going to be 54. Now, I think this one here is a griddable, so you would need to, go and do the little bubble thing. We'll have a bunch of decimals, and then you just write 54, and then you bubble in the correct numbers based off of that there. If there was a negative out front, I think there's a spot for putting a negative. So, anyways, that one's not too bad there. All right, next one here. Oh, forgot to clear this out here. Jenny didn't see that. Oh, so obviously you might have saw what the answer is. But that's okay. We'll talk about where it comes from. Toy is made of cylindrical rings stacking on base, as shown in the diagram. Each diameter, or the diameter of ring 1, is 87% of the diameter of the base. For ring 2 through ring 7, the diameter is still 80% 87% of the diameter of the ring directly below it. So each one is getting smaller by about 87%. Okay, so we got to figure out which of these functions here can help us. So when that's happening, when we're multiplying by 87% multiple times, this is an exponential function. All right, when we got exponential functions, that means you have something that kind of looks like this: y equals a times b raised to x. A is where you start, so it's kind of like your starting amount. B is either your growth or decay factor. So that's what you're basically multiplying by multiple times. So in this case here, we're starting with, I think, a diameter. Where does it say? Base. Oh, here we go. The diameter is 5 inches. That's the biggest one. And then I guess from there, we can go find the rest of them. So we would multiply by 87%. And since we're doing that a couple of times, we'll raise that to x for each layer that we're talking about there. So that would be answer F right there. Now be careful, they might try to switch it up on you. Notice that H is really similar, except it had the A and B value switched around. It's saying you're starting at 87% and then multiplying by 5 multiple times. And if you go and play around with some of the numbers, like plug in 1, plug in 2, plug in 3, you'd probably figure out quickly that there's no way it could be 87, because then the diameters would get very big quickly. If you're taking 87, multiplying that by 5, and then multiplying that answer by 5, it starts getting really big really quick. So definitely not H. G and J, these are both linear functions. When you distribute, it'll look like y equals mx plus b graphs, which means it has a consistent change. That rate of change stays the same. With exponential functions, you're not like adding or subtracting multiple times. You're actually multiplying multiple times there. So G and J definitely aren't it. So that's kind of an explanation of, why the other answers don't work either. All right. What do we got here? 29. Oh, let's see something I need to erase down here. Talk about that here in a second. All right. Sorry about that. All right, let's see here. What are the solutions to this wild-looking thing here? All right, so I have a lot of students. Their first big misconception is, hey, I need to distribute here. Okay, got to be careful with that here. Technically, if you wanted to do that, we would need to take care of this exponent first. And we would need to FOIL this thing. That's going to be a lot of steps there, because then you're going to need a FOIL. Then you're going to have this 2 out in front. It's going to have 2 parentheses, a bunch of junk. You're going to have to distribute it, and it's going to get nasty quick. So there is an easier way to do this one here. What I would do on this problem here is I would take this 2 right here, and instead of distributing in or multiplying by 2, I'm going to get around that by dividing both sides here by 2. All right, if we can do opposites, we can cancel those things out. And then we say, okay, x minus 7 equals, I guess, 16 in this case. Now, just like before, if I want to get out of squaring something, I can do the opposite of squaring something. I'm going to do the square root. So that'll be x minus 7, and then the square root of 16 is 4, but don't forget, though, there's technically 2 answers. If you had like x squared equals 16, there's 2 answers that make that work, positive 4 and negative 4. So we got to put this little plus minus sign out in front. All right, now the last thing we need to do here is actually add 7 so we can isolate x. So I'm going to write this as 7 plus minus 4. And that means there's kind of like 2 answers there. We got to think about what's 7 plus 4 equal, and then also what's 7 minus 4 equal. Whoops, doesn't equal 0. So that'd be 11 as one of your answers, and then I guess 3 as one of your other answers. So there's your answer there on that. Now, I will show you another way here to solve. Once again, there's multiple ways to do these problems, especially if you have the tools of Desmos or your graphing calculators. Say you didn't know how to solve an equation, just had no idea. what I would do is you could take both sides of these equations. So like maybe this whole left side right here, we'll type that in for one of our y's, and then the second equation I'm going to type in for my other y. And I'm going to see where those graphs cross. If I can get them to cross each other, then I can find the multiple solutions, or how many times they cross each other. So I'm going to actually do that here in Desmos real quick. So, Desmos, it really changes the game here. Really makes it nice and easy. So x minus 7, close parentheses, squared. So that was the left-hand side, and then I think it's supposed to equal 32. So that's the right-hand side. I think maybe I might need to say y equals 32. So I'm just going to double-check that. I'm not 100% for sure. And I need to zoom out here. Okay, there we go. So what I'm going to do here now is click on these 2 points right here. So notice there, they have the same y value. Of course, the y value is 32 because you have a line going through those. But you have the 3 and the 11 that we got there. So if you get stuck on solving an equation, that's one workaround that you can do there. You see, you can just set them equal to y and see where the graphs cross. So just kind of using another technique there on getting your answers. Now remember, Desmos, it does take a little bit longer to do some of the things on Desmos, so just keep that in mind. You might not want to use Desmos on every single problem, especially if you really just grasp what you're doing. If you grasp what you're doing, just go ahead and go with your gut there. Desmos is, I would use that to help check, or on the problems where it does truly speed it up. That's what I would use. All right, this is a situational problem here where I think it's asking for like domain or something. Yeah, the total cost in dollars to buy uniforms for the player on a volleyball team can be found by using this function. So give us the equation. We don't have to come up with it. Where U is the number of uniforms by. If there are at least 8 players, but no more than 12 players for the volleyball team, what is the domain for this situation? All right, so domain, we kind of said that in a previous video. I think it was the one previous for this. We said domain. That's like your independent variable, which is kind of like all your x values. All right, now another name for your x values or your independent variable, we can say this is a set of all of the input values, which we need to kind of keep in mind when we're talking about domain. Range, instead of independent, it's the dependent variable. Usually it goes with y. These are your output values. So on this one here, we need to find the domain. So we need to find the set of input values. And if you think about it here, we got to input the uniforms. So we got to figure out how many uniforms are we getting to figure out the cost. All right, so it says there are at least 8, but then no more than 12. So I guess, maybe you're assuming you're gonna have at least 8, but you're not gonna have more than 12. Maybe you have to make some cuts or something. I'm not sure. So that means our values need to be between there. Now think about this too. You cannot sell, or you can't make, half a jersey. I mean, I guess technically you can, but probably in this situation, you're not going to get charged for a half jersey. So you're not going to have like 8.5 jerseys or 11.5 jerseys. So you don't have in between data points. So this is a discrete function here. I think that's C, but whatever. So anyways, it's a discrete function here. So H is probably going to be the best option there. F and G, notice that those are your different costs. Or actually, I'm sorry, G is your different costs there. So we're not dealing with cost. U, this isn't the right domain for the function, because it's saying you can get 0 uniforms, but actually we're probably going to get, a little bit more than 8. So, maybe a better version of this would be U is greater than 8, but then less than 12. J looks like a bunch of money right here, so that's probably going with our output. So that's why H is the best answer there. It's discrete data, so you're not going to have anything in between. Anyways, that is it for this lesson.